Also within section P3, you learn how to do a multiplication of a quantity squared and quantities cubed. So if you did x plus 1 quantity to the first power, we would just get, x plus y, we would get x plus y. If we did x plus y quantity squared, you would get, if you FOILed that out, you would get x squared plus 2xy plus y squared. And then if you FOILed out x plus y quantity to the third power, you would get x cubed plus 3x squared, 3x squared y plus 3xy squared plus y cubed. So now what I'd like to have you look at here is the coefficients in front of these. These are going to, let's see, like in front of this we have a 1 and a 1. Here we have a 1, a 2, and a 1. For the cubed we have a 1, a 3, and then a 1. This is leading you into an idea that is called Pascal's triangle. That looks like this. It starts with 1s all the way down the columns. The way you arrive at the numbers in each of the positions is that, for example, this 1 plus 1 is 2. So you add together the two of the numbers, add together two numbers, and then their sum goes in the position on the next line and in between them. And what you're going to see is on this line when we're squaring, our coefficients are 1, 2, and 1, which is what you saw when we did the foiling on the previous slide. And then here are the coefficients when you multiplied x plus y, or when I showed you x plus y quantity cubed. These were the coefficients that showed up. And by the way, this triangle can be continued on forever. For example, the next line, there's always a 1 at the front. These two sum up to 4. The sum is 6. The sum is 4, and then a 1 on the end. And these would be the coefficients if we were trying to raise a quantity to the 4th power or the 5th power. Those will show up later in Algebra 2 honors. You are only learning squares and cubes in this section. So let's try some examples. If we just wanted to do a quantity squared, we just take the first piece and square it, so x squared. For your second piece, you need, remember in the x plus y, the middle term was 2xy. What that means is we need to take our x times our 6, which is 6x, and double that to get us 12x. And then the last piece comes from taking the last piece, or the 6, and squaring it to get 36. So that's in one of the basic formats. How about when there's one with maybe subtraction and numbers in front of both the x's, and then there's also a constant? For this piece, we have to do, and I'm going to write this step out for you. It's going to be the first piece squared plus 2 times the first piece times the second piece plus the second piece squared. And remember, on this first piece, when you go to square, you have to square both the x and the 6. So 36x squared. The 6 times 5 is 30. Well, with a negative is negative 30. Times 2 is negative 60x. And plus 25. And a reminder that this piece will always be a positive because you're squaring a number or squaring a variable, but that's always going to be positive when you square something. So let's try to apply the pattern also for cubes. We'll do a basic one and a little bit more advanced one. So let's start with x plus 3 quantity cubed. And here are the coefficients from that triangle that you saw, that Pascal's triangle earlier. So what we do is the first coefficient is a 1, and it's not necessary that you write that in because anything times 1, value doesn't change, but I'm writing it in so you can see how this pattern works. So it's 1 times the first piece inside the parentheses raised to the third power. And the second piece doesn't come into play. The plus 3 inside the parentheses doesn't come into play until the second term. And then the x is going to go down in increasing order by exponent once every term. So for the second one, we're going to bring down the 3. That is our coefficient there. So that's going to be a 3 times the first piece, the x squared, times the second piece inside the parentheses, times the 3 to the first power. And then our next piece in the pattern is we have to bring down the next coefficient, which is also 3. We're going to take the x inside the parentheses to the first power, and the 3 inside the parentheses to the second power. And notice again that your powers each time add up to whatever This is 3. This is 3. 2 and 1 add up to 3. 1 and 2 add up to 3. Every time your exponent should add up to the same thing. So and then your last one, we bring down the coefficient of 1. And we now the x's are gone because we've gone from x to the third, to x to the second, to x to the first. We won't have any x's, and now the 3 is going to be raised to the third power. And from here, it's just finishing out the math, doing the multiplications of those numbers. So your answer for this would be x cubed. And then we have 3 times 3 in this one, so plus 9x squared. 3 squared is 9, times 3 is 27, so 27x. And then 3 cubed is plus 27. So let's do one more example where there's a number. We're going to do a subtraction problem, and then there's also going to be a coefficient in front of the x. So 3x minus 2 quantity cubed. We're going to use these same 4 coefficients. You'll use this every time you cube something. You're going to use those numbers 1, 3, 3, 1. So the 1 out in front, again, not necessary if you don't want to write it. And our 3x is going to be raised to the third power. For our second term, it's going to be a 3 out in the front. The 3x is going to be raised to the second power. And on these, bring the negative in to the problem, the negative that's with the 2, bring it down into the problem, because that actually takes care of any sign changes that are going to need to happen here. And which, just a reminder for you, or a note for you, whenever you're doing a subtraction inside the parentheses, your terms, when you go to multiply it out, will alternate signs from positive to negative, etc. So for our third term, we're going to bring down the third coefficient, which is a 3. Now our 3x will go to the first power, and the negative 2 will be squared. And on these, make sure you put your numbers, like your negative 2, inside of a parentheses and the squared on the outside, because that's going to force you to get that negative to become a positive, which is, as I said, your signs are going to change each time. And then the last piece, we can bring down the 1 if you want it, and then it's going to be negative 2 raised to the third. So then again, just doing the math here, 3 to the third power on the first piece is 27x to the third. Now we have 3 squared is 9 times 3 is 27 times negative 2 is negative 54x squared. Then on the third piece, we have negative 2 squared is 4. And 3 times 3 is 9, so 4 times 9 is a plus 36x. And our last piece is negative 2 cubed, so that's minus 8. And this is our solution when you go to multiply any binomial raised to the third power. It may seem weird, or it may seem a little weird or a little difficult to try to get this pattern down at first, but hopefully you can see with just doing this one line of work here, instead of you having to write out 3x minus 2 times itself 3 times and having to FOIL all that, this is, once you get this pattern down, this multiplication is far easier this way. Thanks.